Hey guys, how you doing? It's Mr. Chavla, and today I'm going to be going over the key for part 1 of the Common Core Algebra 2 exam from January 2017. Now, in this video, I'm only going to be going over the final 8 questions, number 17 through 24, because I went over the first 16 part 1 multiple choice questions in the previous 2 videos, number 1 through 8 in the first video, then 9 through 16. Now I'm going to go over the last 8 questions, 17 through 24, and again, this is Mr. Chavla or Mr. C. Now, let's get started. Again, it's the Common Core Algebra 2 exam from January 2017. Let's go, number 17. Okay, what is the solution, if any, of the equation 2 over x plus 3 minus 3 over 4 minus x equals 2x minus 2 over x squared minus x minus 12? Now, we could honestly have just used our calculator, put it in tables and see which one gives us the same answers, the same y values. But what I'm going to do is I'm going to actually do this by hand first, and then we'll confirm in the calculator. All right, so we have 2 over x plus 3. Now, what I'm going to change, guys, 4 minus x is the same as negative of x minus 4, because that's negative x plus 4. Anytime you change the order in which you're subtracting, it's the same as multiplying by negative 1. But these two negatives will cancel, so this will become plus 3 over x minus 4, right, is equal to 2x minus 2. If I factor this, guys, this factors into x minus 4 and x plus 3, or x plus 3 times x minus 4. So now you see why I did that, guys, because I wanted all the denominators to be the same. So what I'm going to do is I'm going to multiply both sides here. First, I need more space. So I'm going to multiply both sides here. And whatever I do to the top, I must do to the bottom in order to keep the fraction equivalent. Right? Being careful with the parentheses. Then I had plus, we had 3 over x minus 4, right? I'll put that in parentheses here. Now I need to multiply both of these by x plus 3. Now all my denominators are equal to the product of x plus 3 and x minus 4. So all I need to worry about now is the top portion, right? So I have 2, when I distribute, it becomes 2x minus 8. Bring down the plus sign, distribute the 3, I get 3x plus 9 equals 2x minus 2, because all the denominators are equivalent. Now, what I'm going to do is, since instead of combining like terms first, if I subtract 2x on both sides, they'll just cancel here. And I just get negative 8 plus 9 is 1, plus 3x equals negative 2. If I subtract 1 on both sides, I get 3x equals negative 3. Divide by 3 to get x equals negative 1. Now, the one thing I want to make sure is that we don't end up, if I look at the original equation, a denominator of 0. So if x plus 3 can't be 0, x cannot be negative 3, which doesn't eliminate negative 1. 4 minus x can't be 0, so x cannot equal 4, so negative 1 is fine. And then the same thing when we look at this one, when it factored into x minus 4, x plus 3, it can't be 4 or negative 3. X minus 4 can't be 0, so x can't be 4. X plus 3 can't be 0, so x can't be negative 3, but negative 1 is fine. All right, so that was choice 1. Just can't be 4 or negative 3, but it could be negative 1. So answer is choice 1. Now you could have used the calculator as well and used the table of values to see which x value results in the same output for the left-hand side and the right-hand side, but I won't do that right now. Number 18, in 2013, approximately 1.6 million students took the critical reading portion of the SAT exam. The mean score, the modal score, and the standard deviation were calculated to be 496, 430, and 115 respectively. Respectively means in the same order. So 496 is the mean. This is the symbol for mean. The mode is 430. That means the mean is average. The mode is the one that occurs most frequently. So more students got 430 on the critical reading than anything else. And the standard deviation, which was the last one, was 115. So that order. Mean, 496. Mode, 430. Standard deviation, 115, respectively, all right? Which interval reflects 95% of the critical reading scores? So guys, what I didn't like about this question is they didn't tell us that it was a, they didn't tell us that it was a normal distribution, but we're going to assume it is. And basically, what you want is the mean plus and minus 2 standard deviations to get the 95% level, right, of confidence. So the interval that reflects 95% of the critical reading scores will be 196 plus and minus 2 times 115. That becomes 196 plus minus, if you multiply 115 by 2, you get 230. 496. I was wondering, something's not right. So 496 plus and minus 230, choice 4. All right, the mean plus minus 2 standard deviations becomes 496 plus and minus 230. All right, so we're going to move on to number 19, and this is about knowing, 18 was about knowing the normal distribution and how to calculate a 95% confidence interval. All right, which statement, number 19, which statement regarding the graphs of the functions below is untrue? So there are 4 functions, f, g, h, and j. And they want to say which statement is not true. They're saying f of x and j of x have a maximum y value of 3. Now, if you look at the graphs, if you understand, like, when the midline is 0, the amplitude, which is the absolute value of the a value, is your maximum. F has a maximum of a, and the absolute value function, since we have a negative here, opens down, then this is a max and not a min, is also 3. But we could confirm in the calculator by just graphing each one. Now, I know you would probably have to enter y1, y2, but let's enter, in this one, I could actually enter it as f of x and j of x, right? I don't need to look at the whole interval. All I need to do is look at the maximum. The maximum y value is clearly 3 for f of x, right? For j of x, if I were to change this one now, I'll unhighlight it. J of x equals negative absolute value 4x. Let me minimize me for now. Minus 2 plus 3. And you could see here that the maximum value is also 3. So since they're saying which statement regarding the graphs of the functions below is untrue, well, this is true, so I'll put a T for true. F of x and j of x both have a maximum y value of 3. So we're not going to choose this one. 2. F of x, h of x, and j of x have one y-intercept. Let's find out. J of x has a y-intercept at 0, 1, right? F of x, which we graphed earlier, has a y-intercept of 0, 0, right? Now, a graph can't have more than one y-intercept, because if it did, it wouldn't be a function, as it would fail the vertical line test, right? But anyway, it could have 0 y-intercepts, right? Now let's see what we got here. H of x is equal to log base 2 of x. Now, the log function does not have a y-intercept in this case, right? Unless there was a horizontal shift. If I enter log base 2 of x, right, it does not have a y-intercept because it gets closer and closer to the y-axis, but never approaches. The domain is only the positive real numbers. The entire graph is to the right of the x-axis, the y-axis. The y-axis, or the equation x equals 0, is an asymptote, right? So this is h of x equals, all right? And if you wanted to confirm, guys, if we just make a table, you'll see that it only works when you substitute positive numbers for x, right? So if I try negative 2, negative 1, it won't work. 0 won't work. But if I even go a little bit above 0, once it's positive, it works, all right? So if I do 0.75, it works. 0.5, 0.25. Well, 0.25 is less than 0.5, right? 1, 2. These are just the inverse of the function y equals 2 to the x power, right? So this is like saying x equals 2 to the y power. 2 cubed is 8, 2 to the second is 4. So there's no y-intercept for h of x. So our answer is choice 2 as to what's untrue. This is saying these 3 functions each have one y-intercept. H of x has no y-intercept. The domain is positive real numbers, or x is greater than 0, right? We could also look at the other parts too, right? So g of x and j of x have the same end behavior as x approaches negative infinity. Let's find out. So if I look at, I'll look at j of x. as x approaches negative infinity, the y values also decrease to negative infinity, right? So for 3, as x decreases to negative infinity, j of x also decreases to negative infinity, right? For g of x, which is the polynomial function, which they factored for us so kindly, let's enter it. And x minus 2. And we need to fix the scale here since the y values are, the maximum is so high, really high. Okay, so about 24 should do it. Let's say 25. We'll go to negative 25, right? And we'll just use a step of 5. And we could see that as the x value decreases to negative infinity, right, so does the y value. So it has the same end behavior. Make sure you understand what end behavior means, all right? So g of x also approaches negative infinity. So they both have the same end behavior as x approaches negative infinity. So that's true, all right? Now, the last one, g of x, h of x, and j of x have rational zeros. Let's just use the graph real quickly to get the zeros, right? Rational, so for g of x, the zeros are the x-intercept. Negative 4 is rational, 0.5, which is 1/2, and 2 are rational, right? Make sure you know the difference between rational and irrational numbers. So g of x has rational zeros, right? And we could have just gotten it from here, 0.5, negative 4, and 2 based on the factors, right? And I made a mess. And 0.5 is the same as a half. H of x, we got the x-intercept was 1, and you'll see that right here, 1, 0, right? So that's rational. J of x will have two rational zeros. One of them is right here, negative 1/4. Negative 0.25 is negative 1/4. 1.25 is 1 1/4, or 5/4. So that's also true, right? So which statement regarding the graphs of the functions below is untrue? Simply choice 2, because it says that all three have one y-intercept, well, that these three have one y-intercept, when in fact h of x has none, okay? Now we could have stopped when we saw choice 2 was untrue, but I wanted to make sure that we showed that the other ones were also not true, okay? So, I'm sorry, that we showed that the other three were true, okay? So we're moving on now to question 20. When g of x is divided by x plus 4, the remainder is 0. Right there, guys. If the remainder is 0 when dividing g of x by x plus 4, that tells me that two things. X plus 4 is a factor of g of x, right? Because if you divide and get a remainder of 0, then whatever you're dividing by is a factor. That's the first thing I know. I'll say A because I don't want to confuse them with the choices. The other thing, by the remainder theorem, guys, g of, if I set x plus 4 equals 0 and get x equals negative 4, g of negative 4 is going to give me the remainder when dividing by x plus 4. So in this case, g of negative 4 should equal 0. But moving on, let's read the rest of the question, right? Given g of x is equal to x to the fourth plus 3x cubed minus 6x squared minus 6x plus 8, which conclusion about g of x is true? Well, keeping in mind that the remainder when dividing by the g of x by x, keeping in mind that when dividing g of x by x plus 4, the remainder is 0, which statement about g of x is true? So first thing, g of positive 4 is 0. No, g of negative 4 should be 0, all right? G of negative 4 is 0. That is true, okay? X minus 4 is a factor? No, no, no. X plus 4 is a factor. No conclusion can be made regarding g of x? No, there are two conclusions. We got them right here. Okay? And we could have confirmed in our calculator, but no need to do that. They didn't even need to tell us what the polynomial g of x is equal to, since they gave us enough information, all right? So we're going to move on to 21, and what you want to study here is the remainder theorem and the factor theorem for polynomials. Okay, 21. Let me make this a little smaller. I would have brought me up, but we're going to need space here. Joel has a credit card that has a 19.2% annual interest rate compounded monthly. All right? She owes a total balance of B dollars after M months. Assuming she makes no payments on her account, the table below illustrates the balance she owes after M months. So the balance is B, the months is M, and the B is measured in dollars. Right? Because they said that right here. So these are all in dollars. All right, and these are the months in the left-hand column. So over which interval of time is her average rate of change for the balance on her credit card account the greatest? So since it's exponential growth, guys, when you have compound interest, it should be the later interval, right? So I'm guessing choice 4, but let's just make sure, okay? So let's just find the average rate of change, which is simply the same as their slope formula, right? Change in y over change in x, but we'll just change that to change in b over change in m, right? So for choice 1, it went from 10 to 60. So we do y2 minus y1, right? X2 minus x1, or m2 minus m1. And we're going to get 50, but let's not even bother with that. We want to find out what the output values are, right? So 2591.90 minus when it's 10, 1172. And we could put the 0.00. And I'll just find out what that is at the end. But right now, let's just make sure we get the correct rate of change formulas. So for 19 to 69, month 19 to 69, we're going to subtract 69 minus 19, which you'll see is 50 months. At 69, we have 2990. And I don't need to put 0.00 at the end if, because that doesn't change the value, right? It's just adding 0 cents. Because remember they said B was in dollars. All right, and at 19 months, it's 1352. And again, I'm not going to bother putting the 0.00. For month 3, and I'll do the same thing. I'm going to take away the 0.00 here. You don't have to do that, but I don't want to run out of space. Right? And I'm going to find out what both of these are equal to. For choice 3, from month 36 to 72, 3135.80 dollars, right? Minus 36, which is 1770.80 dollars. And then choice 4 I'll do on the side over here, or I'll have space here. Choice 4, I'm gonna leave some space, which should be the highest if it's not choice 3. 73 minus 60. At 73 I got 3186. Again, I'm choosing to not put the 0.00, 2591.90. All right, so I'm just going to go into the graphing, not the graphing calculator, the scientific calculator, and calculate each of these. So let's calculate each one at a time and carefully. So for choice 1, 25 on the denominator, in the denominator we have 60 minus 10, 2591.90 minus 1172. That was 2591.90 over 1 minus 1172. And we get 28.398, which is, if you round to the nearest cent, $28.40, right? But let's say we put 28.398. That's the number of dollars per month that it increases on average. So I'll use blue for this one. 28.398, right? Dollars per month, but they're all the same units. So 28.398. Now let's do the same thing for choice 2. And remember, they want to know which one has the greatest rate of change in the balance. So in the denominator I have 69 minus 19, which is also 50, 2990 minus 1352, and you want to be careful putting these in. See what I'm talking about? I put an extra 9 here. That messes everything up. 32.76. And I guess I'll use blue for both of these, all right? Now the next one, I'll just change it to green. So far, they say which one has the greatest rate of change? Well, it's not choice 1 because choice 2 has a higher rate of change, right? Now let's see, choice 3 should have a higher rate of change than even choice 1 or 2. So in the denominator, we have 72 minus 36. In the numerator, 3135.80 minus 1770.80 is about 37.92, right? And I'm not going to make any more than that, so I'm going to put it here. $37.92 per month approximately, right? And now let's look at the last one, and we should get that that's the greatest rate of change. So we have in the denominator 73 minus 60, or you could just put 13. 3186 minus 2591.90. 3186 minus 2591.90 over 73 minus 60 is 45.7, or $45.70 per month. That's $45.70 per month on average that it increased, which makes sense. So this is clearly not the highest, it's the lowest. This is not the highest because choice 4 is higher, and choice 4 is also higher than choice 3. So our answer, guys, is choice 4. I do recommend that you work it out, even though, like, when I was thinking it through, I said, okay, it should be the latter interval because it's exponential growth when it's compound interest. But anyway, it's better to check it out just to make sure, okay? So now we're going to go to the next question, number 22, and we're almost done, okay? And it's just knowing about, the last question was just knowing about average rate of change. So now this one, 22, which graph represents a cosine function with no horizontal shift, an amplitude of 2, and a period of 2 pi over 3? So, guys, there's four parts here. One is that it has to be a cosine function. Now remember, cosine functions look like this if there's no horizontal shift. Horizontal shift would mean that this x, we would have a subtraction or addition next to it in the parentheses. Like in choice 1, see how x plus pi over 3, this was from a previous video, right? Here we have y equals 3 sine x. There's a horizontal shift when we go to the graph of from y equals 3 sine x to y equals 3 sine x plus pi over 3, because the plus pi over 3, it goes pi over 3 left. That's a horizontal shift, all right? But we want a cosine graph with no horizontal shift, okay? Amplitude of 2 and period of 2 pi over 3. So the amplitude is just the absolute value of A is our amplitude, and I'll just call that amp. B is our frequency. That's how many cycles are completed over 2 pi units on the x-axis. C is our midline. That's the average value of the sine or cosine curve. So if the amplitude is 2, if the absolute value of A is 2, A has to either equal 2 or negative 2. Let's see if any of those, first of all, don't work. So here we have 2, 0. Amplitude is how much we increase from the midline, which is in the middle of the middle height, right? It's the average. So 0 to 2, and it goes down to negative 2. So it goes up by 2 and down by negative 2, guys. I'm sorry, it goes up 2, down 2. That's the amplitude, guys. It's how much the curve rises and falls from the midline, which is just the x-axis. So this has an amplitude of 2, all right? And if I look at these carefully, guys, all of these have an amplitude of 2 because they all have a maximum of 2, a midline of 0, and a minimum of negative 2. So all of these have the same midline and the same amplitude, right? So this goes down to negative 2, up to 2, midline 0. So our C value, guys, for all of these is 0. And our A values are all 2 or negative 2. So if I were to work this out, guys, all the graphs have absolute value of A equals 2. So that works for all of them. The period of 2 pi over 3. So one of the things I want to look for, guys, is period of 2 pi over 3 means I complete one cycle in 2 pi over 3 units. So if I look at this one, this is one cycle, right? Right here. But then it repeats the same cycle again, like this. So that's 2 cycles. And then let's say I use green, 3 cycles. It completes 3 cycles in 2 pi over 3 units on the x-axis. The period is how much the distance it should complete for one cycle, not 3. So this is not good. And similarly, this is one cycle, all right? Then it repeats the same pattern, 2 cycles and 3 cycles over 2 pi over 3 units. So this is out because the period for these ones are clearly not equal to 2 pi over 3. So what we want to look for is, we could do this by either finding the equation or by simply looking at the pattern on the graph, right? That these two have a period of 2 pi over 3. Because if you look at this, this is one cycle, second cycle, right? 3 cycles in 2 pi units on the x-axis means 3 cycles, each one has to be 1/3 of 2 pi over 3. So this has a period of 2 pi over 3. If I double that, this is 4 pi over 3 for 2 cycles. And this one is equal to 6 pi over 3, but if I simplify that, that's just 2 pi. And then the same thing goes for this one, because we have, for choice 3, of 1 cycle, right here. You just look for one complete pattern, almost like a wave, right? 2 cycles, and 3 cycles in 2 pi units, which means that our period is again 2 pi over 3. Here we'd have 4 pi over 3, right? And then this will be 6 pi over 3, which is 2 pi. So both of these have a period of 2 pi over 3. So we're down to choices 2 and 3. So both have an amplitude of 2, period of 2 pi over 3. Now which one is a cosine function with no horizontal shift, meaning that there's no addition or subtraction, it's of this form. So if I check, guys, y, it has to be either, let me erase everything here. Not everything, but some of it. Basically, it has to be either y equals 2 cosine. I want to find the b value, right? The period times the frequency is always equal to 2 pi. The frequency is how many cycles are completed over over 2 pi units on the x-axis. So b should equal 3, because if the period is 2 pi over 3, that's p, times b equals 2 pi. We'll multiply both sides by 3 over 2 pi. That becomes 6 pi over 2 pi, which is just 3. If you divide by 2 pi over 3 or multiply by 3 over 2 pi on both sides. So it should be 2 cosine of 3x, and all of them have a midline of 0. So it should be either that or negative 2 cosine of 3x. Because remember, a has to be 2 or negative 2 for the amplitude to be 2. Now let's just make sure we get the right values here, right? So we don't need any of this anymore. Let's see what happens if I substitute 0 for x, right? Y equals, I'll call this y1 and y2, right? y1 equals 2 cosine of 3 times 0 is 0, right? Cosine of 0 is 1, and 2 times 1 is 2. So we don't have that, but if I change it to y2, which is equal to negative 2 cosine of 3x, 3 times 0 is 0, cosine 0, 1, 1 times negative 2 is negative 2. So it starts at negative 2, it goes up to the midline, up to positive 2, and down to negative 2. And you could confirm in your calculator that this is actually the equation we get. This is our equation, all right? Our answer is choice 3. You could use your calculator to confirm using a table of values or just seeing the graph, but I won't do that right now, okay? So answer is choice 3, and you just need to know your sine and cosine curves. All right, we're going to move on to 23 now. According to the pricing website, or a pricing website, Android phones lose 58% of their cash value over 1.5 years. Which expression can be used to estimate the value of a $300 Android phone after 1.5 years? So guys, very simply, if in 1.5 years you lose 58%, you end up multiplying by 1 minus 0.58, which is 50% as a decimal, after 1.5 years, right? So 1 minus 0.58 is 0.42. Let's find out what 300 minus 0.42 is. I'm sorry, what 300 times 300 times 0.42 is equal to $126. So the value of an Android phone after 1.5 years should be about $126, right? So let's just see which of the three expressions, there were other ways to do this, give us a value closest to $126. So 300 e to the negative 0.87, 300 e to the negative 0.63, and I'll see what they're all equal to afterwards. 300 e to the negative 0.58, and it's only going to be one of them. The other ones will be far off. All right, let's see which one gives this to us. What? Oh, because I made it positive here. All right, and I could put the zeros in front even though it's not necessary. So let's go, 300 e to the negative 0.87 is very close to 126. It's about $125.69. This is very close. The next one is way too high, way above 126. And then it gets even higher to 168 almost, to almost 200. So the answer is only going to be 300 e to the negative 0.87. It's choice 1. All right? because this is about 126. The other ones are way too high, all right? There were other ways to do it, but that's the way I decided to do it this time. Now, last one, guys, number 24. A cardboard box manufacturing company is building boxes with length represented by x plus 1, width by 5 minus x, and height by x minus 1. The volume of the box is modeled by the function below. So, guys, remember this. Volume is equal to length times width times height, right? So if they're telling you what the length, width, and height are, the function is simply going to be v of x. Let's try it again. V of x, right, is simply going to equal the product of the length, the three binomials, 5 minus x and x minus 1, which means we should have zeros at x equals -1. Remember, if x plus 1 is a factor, remember from an earlier question, then x equals -1 is a 0, v of -1 is 0, v of positive 5 should be 0 because 5 minus 5 is 0, and v of positive 1 should be 0, which we got right here. So this is what we should have here, this graph. So they're saying over which interval is the volume of the box changing at the fastest average rate. What I'm going to do, guys, is I'm actually going to go here, clear all this out. I'm going to make a table just to make sure we got the right graph. Then we could get the exact values rather than estimating. So I'll say v of x equals x plus 1, 5 minus x, and x minus 1, right? And I'm going to change the scale so it matches exactly what we have here. So the maximum x value is 6, right? I'll just go over a little bit to 7. And the minimum is -2, so I'll go to -3 just so we have a little more space because this graph is a little weird. And it goes up by 1 each time. On the y-axis, it's going up by 2 each time, right? So I'm going to change the step to 2. The minimum is, it goes down to -8. So let's say that I just make the minimum -10. The maximum it goes to is 20 on the graph, right? Like on the scale. So I'll just say we go up to 22, and we'll use a step of 2. And let's see if I get the same graph. All right, I do indeed get the same graph if you check this out, guys. It's kind of hard for me to be able to show both of them at the same time. But if you check, guys, it's the same exact graph, and we could confirm, all right? This maximum value is about at 3.43, 16.9, which is what we got right here. About 3.43, 16.9, because 16 is right here. All right, so we don't need to get into all that detail, but we just want to make sure that we got the right function. So now the reason that this is helpful is because we could make a table of values, right? I don't even need the graph anymore. I want to get the table. All right, and I just want to see, right? I just want to see what the values are. So starting at 1 and 2 is to get the average rate of change, right? Because they're saying over which interval is the volume of the box changing at the fastest rate. So if you do y2 minus y1, just like in the previous problem, right? For this one, it'll be 9 minus, the y is 9 minus 0 over 2 minus 1. That becomes 9 over 1 equals 9, right? So for this one, it's 9. I'll put that over here. From 1 to 3.5. At 3.5, it's 16.875. So for choice 2, and we could see that right here, 3.5 is about 16.875 because 17 will be here, right? So 16.875 minus when it's 1, it's 0, over 3.5 minus 1. That's 16.875 over 2.5. All right, and you could have just put it in the way it was, but I thought it was easier to just put these instead. This is 6.75. So it's clearly not as much in choice 2 as it was in choice 1, and they want the fastest, right? Now from 1 to 5, they're both 0 at 1 and at 5, right? So there's going to be no change, right? Because v of 1 and v of 5 are both 0. So it's going to be v of 5 is 0 minus v of 1, 0 over 5 minus 1 is 0 over 4, which is just 0. But we didn't need to do that. If you look at the graph, the change is 0. It's a slope of 0. So that's not the fastest. 0 to 3.5. Remember when we did 3.5, we had 16.875. It's going to be over 3.5 minus 0. And when we have 0, so I'm going to enter an extra column. It's -5, which makes sense, guys, if you check it out. The original function, if you multiply 0 times 1 is 1. 5 minus 0 is 5. 5 times negative 1 is, 0 minus negative 1, sorry, 0 plus 1 is 1. 5 minus 0 is 5. And 0 minus 1 is negative 1. 1 times 5, 5 times negative 1 is negative 5, which is why we get negative 5 for the y-intercept here, right? And I'll just show you guys right here. Negative 5 is the y-intercept, and that shows right here too. So anyway, so that means in the numerator, guys, I made a mistake. In the denominator, x2 minus x1, we should have 0 down. Oh, I'm looking at the wrong one. Here we go, down here. Minus negative 5, right? Because it's y2 minus y1. That becomes 16.875 plus 5, right? 6 over 3.5. Or I could put minus negative 5. And that's 6.25. So that's clearly not the fastest rate of change either, right? That's 6.25. So 4 is not the fastest. It's choice 1, guys. Choice 1 is the interval over which the volume of the box is changing at the fastest average rate, okay? I'm sorry if I went into too much detail with that. I realize I might have gotten carried away. But anyway, I hate when that thing comes in front of my face. Anyway, thanks for stopping by, guys. I hope you found this video useful. Please study, alright? Do the best you can. Have faith in yourself and don't stress out. If you have any questions, let me know in the comment section below. If you'd like me to go over something in more detail or kind of a different way, I understand, and I'll be more than happy to go over it, right? Help each other out too, alright? And if you enjoyed the video, please hit like, subscribe. Please send your friends over if you think that they would benefit from this, alright? Thank you so much and best of luck to you, alright? And I'm going to continue the part 2 in another video, but not today, alright? Because I think I had enough for today. Bye for now. Good luck, guys. Bye.